Okay, so our next speaker is Mark Daniel from Infineon Technologies UK Limited. Mark is a senior staff engineer in verification. He's going to be speaking about merging, ranking, and metrics reporting, unified regression reporting flow using ranking. Mark has been with Infineon for 18 years and worked on the verification of third-party and in-house IP and CPUs, and has expertise in constrained random verification environments. More recently, he has taken responsibility for tools and flows, enabling best-in-class tools used, as well as compliance for ISO 26262. Prior to working at Infineon, Mark worked at GEC Plessey Semiconductors, Mitel, on the development of IPs and SoCs for the set-top box market. Mark has a BEng in electrical and electronic engineering from the University of Bath. Okay, Mark?
Thanks, Mike. Can everyone hear me? Yeah, it's difficult up here. Okay, so let me explain. One of Mike's contractors is working at Infineon, and he wrote the abstract for this. And
Get my excuses early.
yeah, I'll get my excuses early. So the suggestion was that someone from Infineon should present it, and Bala and Daniel were both working together. Daniel wasn't able to make it, so I'm afraid you've got me. Okay.
How many excuses you trying to make?
Okay, so I'm going to talk through our regression cycle that some of the IPs have been using, and the CPU, and how we handle debug, and a bit about tracking of statistics and various things. Okay, so there are coloured boxes on my screen, but they can't be seen up there. So, okay. So the regression cycle. So what we're talking about. So in Infineon, we're working on a fixed version of RTL and testbench. So we'll take a labelled version of the both, and we will run a regression. So that's thousands of constrained random seeds, or it could be formal properties that we run a regression. This gives us. So the problem with regressions is that you get failures, and you get coverage holes. We then have to debug them, which we're down here. Honestly, there are boxes here. And then we fix bugs in the design, all the test bench, all the coverage code, and then we go through the cycle again. So this is something that could happen on a daily basis, depending on your project, a weekly basis, or if you're on a very small project, it could be an hourly basis. Okay. The project that Bala was working on, it took them 150 cycles of this to get from 25% of their coverage to close to 100%. And then on a derivative project, it took 40 cycles to go from 89 to 100%. So each cycle was collecting coverage. Yeah. Okay. So one of the big problems with running lots of regressions on a daily basis, you get thousands of seeds run each day. And debug is our biggest problem. So you can have hundreds of failures to debug on a daily basis, and if you've only got a limited number of engineers to debug them, it can take a long time. Or you can never actually debug all the failures that you get each day. So you have to make decisions. Do you keep the failures? Do you throw them away, ignore them, and hope that we find them again in the next day? Because one of those hundreds of failures, if you've thrown it away, may have actually been the critical RTL bug that your constrained random environment only found on that day. So we don't want to lose that. How do you focus debug to the right failure? If you've got hundreds of failures, you might actually pick up the same problem every day. How do you stop people debugging the same issues? If you've got a team of people debugging, if you've got 100 failures, they all usually choose the easiest one to debug first, yeah? So 3 people will go and debug the same test and maybe come to the same conclusions. Okay, so what we've introduced is a triage process. So let's put some boxes. Okay, which are the ones to highlight. Okay, so we've extended the regression cycle here. So we've added our triage. What we mean by triage is it's an automatic process that runs as part of the regression. So it runs post-simulation, and it analyzes, so it produces a category for your failure. So it does some level of automatic debug. So it does some level of debug, but it's trying to think what I'm trying to say. So it basically takes hundreds of failures from a run and reduces that maybe to 5 separate categories. So it's automatically targets you to 5 different failures. And you may have already determined that 4 of those failures in previous runs. So there might only actually be 1 new issue to debug today. So then your debug effort is reduced. And then these categories are, and the tests are stored in our issue tracking system. So then this allows feedback into the triage system so that it can determine that you've already debugged this problem and you can ignore this one until it's been fixed. One thing it allows is us to have known failures in a regression. So what I mean by that is we always have a target of achieving 100% pass rate in a regression for some reason. That's what project managers like to see. But sometimes there are known issues with your verification environment, which causes you to get to a corner case which you're not particularly concerned about, but it's harder to write your constraints than to fix it than it is to just allow some failures through. Okay. So what I'm doing here is there's no need to over constrain it to 100%. So one of the presentations this morning in the safety environment safety track was talking about it's possible that if we constrain things to what we understand, then we're probably not testing everything. And the triage system also allows us to track who is debugging, so it has a web GUI which reports all your failures, categories, and it does actually do a debug and get on the test and grab it. Okay, so that's debug and triage. So another thing that we do in our regression is to, so with constrained random, it's very difficult to get a set of seeds for our IPs anyway, which you can get full coverage in one run. So we're talking, so we're trying to produce a regression that will give us our full coverage, but to do that we need to, here is rank our coverage and keep the tests. So some people talk about this as a golden regression, so this is what we're talking about here. So we rank our newly constrained random tests against the previously kept ones, and then add anything that is adding to new coverage. So this allows us to keep tests which are only hitting coverage corner cases once every month or once every 3 months. So Bella's example was that initially we were adding 300 tests per cycle to this session through this route, and then but by the end of the project, as we went around the cycle lots of times, we were probably only adding 10 per cycle. So this is ranking against code and functional coverage. With the triage system, we can now add useful failures into our sessions so we don't lose them. So, and if we don't even get to debug all of our failures, we can actually feed them into the next regression and keep them for the next loop. So by adding failures to our next regression like that we do, we ensure fixed. So when the designer maybe fixes a piece of RTL, we add the failure from that fixed, from that identified that bug to our regression. So then when they go find that they've actually broken something else, they can, by keeping the test there, the next time they go and reverse their fix, i.e. put the bug back again, they can actually test before they commit their code, they've kept all of their fixes, or all the tests are still passing. So yeah, one question maybe is, do you keep all of your failures, or do you with the triage we can optimize and say, let's keep one of our tests from each category from the regression. Okay. One key point that Bala wanted me to make was that this session contains our golden coverage. It also contains our failures, and it also contains new constrained random tests. So pointing to the word session, you might point us towards vManager and that sort of thing. So we'll generate one vSIF in here, which contains all of these different parts of the regression. Okay. So yeah, so this session is updated automatically based on the output of triage, output of coverage ranking, and new seeds. Okay. So when you're working on a cycle where you're trying to keep your regression relatively clean, because if you're trying to collect coverage, what you don't want is lots of failures from your golden regression. Otherwise, you lose a lot of coverage, and so you'll be adding lots of new tests which happen to pass but hit the coverage. So we need to ensure that we keep clean code. So another thing that we've done is, how am I doing for time? Are you running out? Okay. So how do we ensure good quality commits? How do we avoid losing that daily cycle and wasting resources on unnecessary, avoidable failures? So now we've got a quality control regression which everyone who's working on RTL, all the test bench uses to ensure that their commits still work and don't break everything. You might call it some people call these mini regressions, coffee break regressions, or a gatekeeper regression. So some of the points we have is that this should be less than 10 minutes to run. It's used to qualify RTL or test bench changes. If this fails, changes are not committed, obviously. Okay, we automatically update this regression with failing test cases from known fixed RTL bugs. And so this ensures we have good quality commits. I think these points are the wrong way around. So what we also add is short, high coverage yielding tests. So if you to match this, we need short tests. Yep. So typically the number of tests in this regression are less than 400, and about half of them are coverage-based tests. The rest are fixed RTL bugs from the design. Okay, what's next? So, yeah, so with all of these things, so if you've got a daily cycle, we need to track how we're progressing. So how do we know we're making progress with each cycle? We track a number of things. So here's an example of some of the things we track. So obviously one is functional coverage and code coverage. We're aiming towards 100%. One thing you might look at here is tests ranked and adding to coverage. So this is where we're ranking and how many tests are adding to new coverage holes. So if we're not adding anything to our coverage and we still have coverage holes, where are we actually testing anything new? Yeah. So if this number goes to 0, then our constrained random environment's probably not testing anything useful beyond what we already have tested. We track how many new failing tests we're adding. So how many new failure categories have we got? How many so this is how many needs debugging. This is categories that we have already debugged. Failures, and then the number of failures we're adding to the regression as well. We're also tracking how many issues we've raised and how many bugs have been fixed, which are other obvious ones. So, so we've developed a tracking dashboard which allows, so this tracks our metrics, references log files, and reports and results. We collect this on a per regression cycle basis. So and we can look back across the project and see, we can go back to the report for the regression 3 weeks ago and see what went wrong then, and yeah, various things. We can. So this is automatically updated from regression scripts. So in the case of, let's say, vManager, in your post session script, you might have something which posts all the results into this automatically, so it's viewable. It's not a manual process to put it in here. And then all these results are viewable by a web-based interface. So all our project managers where I work seem to like this because they can see how the regression is progressing. They can track, see how functional coverage is progressing with real numbers. You can see things go down as well as up. Code coverage. This is showing our triage categories per regression. So this is categories without RT. So RT is our issue tracking system we're using. So this is, so here you can see the most categories that we had without an RT at one day was 5 minutes. I'm nearly there now. It's about 35, but here if we looked at the number of failures with over 2,000 in our regression, that might have been slightly daunting for our engineers to look at. But yeah, so this is basically looking at the tracking and how we're tracking things over time. It's difficult to go into details, but yeah, how to cover. So in summary, small changes make a big difference. So there's nothing massively clever that we're doing. We're just using some small things to help improve the whole efficiency of the team. Yeah, one key point, which don't over-constrain your random test benches. It stops them testing stuff that you may not have understood or may not think you need to test. Passes are cheap, but failures are valuable and they point us towards a bug. It's okay to have failing test cases as long as they're not RTL bugs. And we've reduced our debug effort and yeah, okay, that's about it, yeah.
Thank you very much, Mark. Thank you. Interesting talk. I'm going to take credit for that talk. Very interesting. I find that very practical, very useful. So any questions from Mark? I've got 2. Oh yeah. Go to Mike first, and then we'll pass over.
Yeah. So I did. You'd mentioned the failure triage and the categories. Yep. Are they based on error signature, or how are you defining the categories?
Yeah.
So we look at log files from simulation. We look at trace files from whatever. Yeah. So we're in the CPU. We might have trace files coming out of what events are happening, and we'll look at those. And so we can do an intelligent look at log files or error messages, for instance, or yeah. So we can actually say, yeah, this error message is only happens when this sort of event is happening as well, and so we can use that to categorize. So or if you have a error message that says, I've got a byte read failure inside this range in this memory or at this address, we actually analyze it and go, well, that's just our DSPR memory. So all of those, so you might have a byte read error across 240K memory. So you can have 240,000 different error messages. You can bring them all down to one, just to say you've got a byte read error on your DSPR.
You assign the category automatically based on this?
Okay.
Yeah.
That's good. Sounds like good use for AI as well, I guess. There's a project in there somewhere. Yeah. Actually, debug's interesting because I think debug is one of the things we haven't really changed that much over the years. Yeah. Making debug more efficient is a good.
It's almost same question, but just want to know that when you report so you said that reported issue, it's made the failure to existing reported issue. So when you report an issue, it need to be in some standard format so that when you go and match with a log file, you can see the match.
So the report the issue. So okay, so that it's like
I'm assuming you must have some sort of, let's say, Zira or some kind of a commercial tool to reports and
yeah. So we're using something called RT. It's a free tool. But
Okay.
you could be using Jira, you could be using lots of different issue tracking tools. And then we have a special field in the system for storing the category and also which test. So if the test changes category, we would consider it not still covered by the debugger that's been done.
Okay, good, thank you.
Okay. Yeah, it's a question about, I've got about 3 questions on that. I'm eager to ask.
This is Chris Brown from Arm in Cambridge. I'm interested in this idea of taking tests that you think have got lots of coverage and adding them to your suite or ones that have failed. And whenever I've tried to do that in the past, the tests haven't lasted that long. So any kind of changes to the test bench hits your random stability. Tool vendors do a great job of trying to keep things stable, but there's a limit to what they can do. Do you have problems like that, or have you solved that?
Yeah, so that's always the problem with constrained random. If you've got a purely constrained random test bench and you change the RTL, you can have a different test. Yeah, even so we do that in 2 ways. So for a purely constrained random, we might reevaluate all the tests inside our golden regression and go, all right, we've got too many now. Which ones actually give us all our coverage? We'll keep the failure ones as different. The coverage is different. Yeah. Another way we do it is to we generate tests, but just have a replay mode where we simulate them in replay mode. So that means we don't change the generation each time. If that makes sense.
Thank you. Thanks, Mark. Just quickly, I wanted to follow up on Mike's question as well, because I find the automatic triage very interesting, possible for AI as well. Can it also say the shortest trace to the failure in that category?
So so it lists all of the failures in that category, but it also reports the time of failure.
All right, so and the shortest trace to that failure, the shortest simulation, so you can reduce your debug time as well.
People going into debug will look at category and just take the first one, because that's the shortest.
Very practical. No, it sounds very good. Thank you very much, Mark.